In our previous lesson, we reviewed how to add and subtract fractions. Well, continuing along the same theme, let's look at multiplying and dividing fractions as well. So suppose we want to multiply 3/5 by 4/7. Well, one way we could represent that product is with an area. If you remember, the area of a rectangle is its length multiplied by its width. So if we can create a rectangle with a width of 3/5 and a height of 4/7, its area represents the product that we're interested in. So let's start with a one whole area square. To do that, our square needs to have a width of 1 and a height of 1. Multiplying those, we get our one whole. To represent 3/5, let's split the square into 5 parts. And we'll use vertical lines for this. Once we have this split, we can take 3 of them, and that represents 3/5 of a whole. Now to represent 4/7, we're going to use the other side of our square. So we'll split our square into 7 parts, and then 4 of those represent the fraction that we're interested in. So if we take those two lengths and shade the rectangle that they form, we get an area representing the product we're interested in. Now, we just need to work out what fraction of the whole this represents. If we look at the whole square, we can see that we've split it into 5 sections one way and 7 sections the other way. The total number of sections we've made is 5 times 7, which is 35. If we want to look at the number of sections that make up the area we're interested in to represent our product, we can see that there are 3 sections one way and 4 sections the other. The total number of sections we've shaded is 12, or 3 times 4. Notice to get these two numbers, we were multiplying the denominators of our two fractions and multiplying the numerators of our two fractions. So the fraction of the whole that our shaded area represents is 12 parts out of 35. But we really found that by multiplying 3/5 by 4/7. So in practice, to multiply fractions, we can multiply the numerators to get the resulting numerator and multiply the denominators to get the resulting denominator. Now, if the numbers that we're working with aren't all fractions, there's a few things we can do. If we're multiplying an integer by a fraction, we can write the integer as a fraction using 1 for the denominator. If we want to multiply a mixed number, we can write it as an improper fraction first and multiply exactly the same way as we've just seen. Now, in some circumstances, there may be more efficient ways to find our product than converting integers and mixed numbers into improper fractions. However, this method will always work, and with practice, we may learn to discover some of those situations where we can solve these problems more efficiently. For now, let's look at these examples. So, if we have 4/9 times 3/8, we get 4 times 3, which is 12, and 9 times 8, which is 72. So we have 12 70-seconds. Now we should simplify if we can, which we can in this case. This is 1/6. If we have 2 and 4/5 times 1/7, we should change our mixed number into an improper fraction, which would be 14/5. So we have 14 times 1 for the numerator, which is 14, and 5 times 7 for the denominator, which is 35. 14/35 simplifies to 2/5. Let's look at an example where we have a negative number. Now the rules here for multiplying negative numbers are exactly the same as what they would be if we were just handling integers. So we have a negative multiplied by a positive, so our result will be negative. Then multiply our numerators. 3 times 20 is 60, and 10 times 9 is 90. So negative 60/90ths, which simplifies to negative 2/3. Now in an earlier lesson we talked about the additive identity, which is 0. It's a special number that when you add it, it doesn't change what the other number is. Well, we also have a multiplicative identity. In this case, this is 1, because its product with any other number is the other number. Related to this is the reciprocal, also called the multiplicative inverse, of any number is another number which when they're multiplied together result in 1. As an example, let's check that some given pairs of numbers really are reciprocals. So 5/6 times 6/5. When we multiply their numerators, we get 30, and multiply their denominators, we also get 30. This simplifies to 1. If we have 1/7 and 7, well, we can write this as 1/7 times 7 wholes, which equals 7/7, which is equal to 1. If we have 1½ and 2/3, we can write this as 3/2 times 2/3, which is 6/6, which is also 1. So notice in each of these examples, when we multiplied them, we ended up with 1, which means the numbers are indeed reciprocals. Now, the reciprocal of a proper or improper fraction can be found by switching the numerator and the denominator. And you can see that in the examples above. Each time we wrote out the product with a plain simple fraction, both proper and improper fractions, the two fractions were the same except the numerator and denominator were switched around. Earlier, we represented a multiplication problem using area. Now, we're going to try and do the same thing here for division. This is a little more complicated, and if you don't entirely understand what we're doing here, that's okay, but try and follow along and see if you can understand why division works the way it does. So, we have two squares. Each of them represent one whole. We're going to shade one with the area of 3/4, and we're going to shade the other one with the area of 2/9. We're wanting to show how many times 2/9 fits inside 3/4. In other words, we're finding 3/4 divided by 2/9. Now, to make these two areas more comparable, we're going to split both squares using the other square's number of divisions. This might sound a bit weird, but what it means is both squares end up with 36 sections in total. This means we can directly compare the number of sections that we've shaded in each shape. So, how many small sections make up 3/4? Well, we have an area which is 3 sections wide and 9 sections high. So, the number of sections it has is 3 times 9, which is 27. How many sections does 2/9 take up? Well, we have an area which is 4 sections wide and 2 sections high. So its number of sections is 4 times 2, which is 8. So the question of how many times does 2/9 fit into 3/4 is the same question as asking how many times does 8 fit into 27. Well, if we take our 3/4 area, let's see how many times we've got 8 sections within that area. By splitting up, we see we have it once, twice, 3 times, and then we have a little bit left over. Well, these 3 sections that are left over are 3/8 of that area we were trying to fit in. So the number of times it fits is 3 and 3/8. Well, 3 and 3/8 is actually the same as 27/8, which shouldn't be surprising because we were trying to fit 8 sections into 27 sections. Now we can see that we got those numbers 27 and 8 by multiplying 3 by 9 and 4 by 2. But we know what we were actually trying to represent here, which was division, 3/4 divided by 2/9. Well, we've just shown that 3/4 divided by 2/9 is the same as 3/4 times 9/2. What we've done is we've changed a division into a multiplication by taking the reciprocal of the second number. Now, if we actually stop and think about it, this makes sense because the reciprocal is what we call the multiplicative inverse, as in it's the opposite number when it comes to multiplying. And division is the inverse process of multiplying. So as some examples, let's look at evaluating some quotients, that is division problems, using this method. So 5/4 divided by 7/8 is the same as 5/4 times 8/7. Remember, the first fraction doesn't change because it's not the one being divided. The second fraction is the one being divided, so it's the one we take the reciprocal of. This evaluates to 40/28, which simplifies to 10/7. 3/4 divided by 6 is the same as 3/4 times the reciprocal of 6, which is 1/6. Evaluate that and we get 3/24, which simplifies to 1/8. 2/3 divided by -6/11. Take the reciprocal of the second fraction, we get 2/3 times -11/6. When you take a reciprocal, the negative just stays exactly the same as it is. Multiply these together, we get 22/18, which simplifies to -11/9. If we have some mixed numbers, such as 2 1/3 divided by 3 2/5, we can write these as improper fractions. So 7/3 divided by 17/5. Changing this to multiplication, we have 7/3 times 5/17, which is 35/51. 9 divided by 3/4. We can write the 9 as a fraction as 9 wholes, or 9/1, times the reciprocal of 3/4, which is 4/3. We get 36/3, which simplifies to the whole number 12. Then if we have -2 1/5 divided by -3, so this seems complicated because it's a mixed number divided by an integer. However, we can write our mixed number as the improper fraction, -11/5, and we can take the reciprocal of our -3 as -1/3. Multiply these together. Negative times a negative means we have a positive result, and we have 11/15.